Wave packets. From what was said above, a wave function constant throughout all space cannot give information on the position of the particle. They suggest that a wave function that did not have the same amplitude throughout all space might be a candidate for giving such information. In fact, since what we mean by a particle is a physical object that is confined to a highly localized region in space, ideally a point, it would be intuitively appealing to be able to devise a wave function that is zero or nearly so everywhere in space except for one localized region. It is in fact possible to construct from the harmonic wave function a wave function which has this property. To show how this is done, we first consider what happens if we combine together two harmonic waves whose waves numbers are very close together. The result is well known. A beat note is produced, that is, periodically in space the waves add together in space to produce a local maximum, while midway in between the waves will the totally out of phase and hence all destructively interference. This is illustrated in this figure, where we have added together two waves, cos into 5x plus cos into 5.25x, means the angle over here we will change. It is not cos x, cos 5x plus cos into 5.25x. Okay. Beat notes, these are the beats notes produced by adding together two cos waves. Okay, in the first figure. Combining in the second figure, combining 5 cos, it is 5 cos waves, which are, what are those 5 cos waves? So first is cos 4.75x plus cos 4.875x plus cos 5x, and the next is cos into 5.125x. The last is cos 5.25x. Now look at the third figure, which is figure C, combining 7 cos. We are not combining 5 cos over here. Okay, here we are combining 7 cos. The first is cos into 4.81, and the second is cos into 4.875. The third is cos into 4.9375, and the next is cos into 5x only. Okay, plus cos into 5.0625 into x plus cos into 5.125x plus cos into 5.1875x. Okay, and the next figure is an integral over a continuous range of wave number produces a single wave packet, means the last figure is. This is an integral over a continuous range of wave numbers produces a single wave packet. Now suppose we add 5 such waves together, as in second figure, which is figure B. The result is that some beats turn out to be much stronger than the others. If we repeat this process by adding 7 waves together, but now make them closer in wave numbers, then we get the third figure, which is figure C. We find that most of the beat notes tend to become very small, with strong beat notes occurring increasingly far apart. Mathematically, what we are doing here is taking a limit of a sum and turning this sum into an integral. In the limit, we find that there is only one beat note. In fact, all other beat notes become infinitely far away. This single isolated bit node is usually referred to as a wave packet. We need to look at this in a little more mathematical detail. We could equally well have used a sine function or indeed a complex exponential. What is found is that it is the limit in which the sum becomes an integral. Okay, just like as psi into x comma t, which is equal to minus infinity to plus infinity a into k, this is a parameter, cos into kx minus omega t dk. All the waves interfere constructively to produce only a single bit node, as illustrated in figure D previously. The wave function or wave packet so constructed is found to have essentially zero amplitude everywhere except for a single localized region in space. Over a region of width 2 delta x, that is the wave function psi into x comma t in this case takes the form of a single wave packet as illustrated in this figure. So what this figure describes? The distribution of wave numbers k of harmonic waves contributing to the wave function psi into x comma t. This distribution is peaked about k bar with a width of 2 delta k. The wave packet psi into x comma t of width 2 delta x resulting from the addition of the waves with the distribution a into k. The oscillator part of the wave packet, the carry wave, has wave number k bar. Okay. This wave packet is clearly particle-like in that its region of significant magnitude is confined to a localized region in space. Moreover, this wave packet is constructed out of a group of waves with an average wave number k bar, and so that these waves could be associated in some sense with a particle of momentum p bar is equal to h cut k bar. If this were true, then the wave packet would be expected to move with a velocity p bar over m. This is in fact found to be the case as following calculations. So we are not follow the calculations over here because here we are discussing the theoretical description of quantum mechanics.